Hello, I'm Shai Almog, and I want to help you solve your production issues. I love APMs. They are absolutely wonderful. This is absolutely amazing. I can instantly get a detailed view of everything in my production app. This tool is especially useful for the DevOps who can instantly see which resources are stretched thin. As a developer, the APM is a useful tool, but it has its limits. It doesn't point me at a line of code. So let's stop for a second and talk about a different line. This line. On the one side we have developers, on the other we have the ops or DevOps. This is a line we've had for a long time. It's something we drew out of necessity because when developers were given access to production, well, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago, yet we had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation because the ops guys don't necessarily know how to solve problems made by the developers. They know how to solve ops problems. When we find a production problem in a container, we end up stuck in this loop of add a new log, go through CI/CD, which includes the QA cycle and everything. This can take hours at least. Then reproduce the issue in the production server with your fingers crossed, and try to analyze what went on. Hopefully you found the issue, because if not, it's effectively rinse repeat for the whole process. In the meantime, you still have a bug in production, and developers are wasting their time. There just has to be a better way. It's 2022. We need something that's more dynamic. But we don't want to break the gains made by DevOps over the past decade. We need a new tool that will solve the problems of dynamic redeploy, but won't lose the gains we made with the DevOps separation. We also wanted to integrate with all the amazing richness of Elastic. I want my logs searchable in the same place. Before we go on, I'd like to explain what's continuous observability. Observability is defined as the ability to understand how your system works on the inside without shipping new code. The without shipping new code portion is key. But what's continuous observability? With continuous observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With continuous observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? Each tool in this field is different. I'll explain the Lightroom architecture since that's what I'm familiar with. We use a native IDE plugin to VS Code or JetBrains IDEs such as IntelliJ, PyCharm, WebStorm, etc. We can also use a command line tool. The client lets us interact with the Lightroom server. This hides the actual production environment. Production is still the purview of DevOps. We can insert an action, which can be a log or a snapshot or a measurement metric. Notice that the Lightroom server can be installed in the cloud as a SaaS or on-premise and managed by ops. The management server sends everything to the agent, which is installed on your production or staging servers. This means there's clear separation between the developer and production. DevOps still has that guarding line. That means no danger to the running production servers from a careless developer, well, like myself. The agent is a small runtime, it's very low overhead, and it implements the debugging logic. Finally, everything is piped through the server back to your IDE directly. So as a developer, you can keep working in the IDE without leaving your comfort zone. This is the prime main app in Kotlin. It loops over numbers and checks if they are prime numbers. It's a pretty simple application that just counts the number of primes it finds along the way and prints the result at the end. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add a metric. Selecting log opens the UI. To enter a new log, we can write more than just text in the curly braces. It can include any expression, such as the value of the variable that I included in this expression. I can even invoke methods. After clicking OK, we see the log appearing above the line in the IDE. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but it's all in Elastic too. Also notice the last line of the log. If we take too much CPU while logging, Lightroom pauses the logging so we won't impact runtime performance of the server. In this Java-based project, I'd like to show a different feature, which is a snapshot. It's a breakpoint that doesn't stop program execution. Users of a live system won't be disturbed, but you can still get the stack trace and all the variable values that you would need. Lightroom works on all JVM languages, JavaScript and TypeScript with Node, Python and other languages coming soon. There's a lot more to discuss about all of this, but unfortunately there isn't much time. I hope this quick intro helped you get a sense of continuous observability. Please check out talktotheduck.dev, where I talk about debugging in depth, and check out lightroom.com, which I think you will find interesting. If you have any questions, my email is listed here, and I'll be happy to help. Thank you.